Greetings and welcome once again to my new calculus channel. So I'm John Gabriel and I'm going to explain to you, hopefully for the last time, what the Holy Grail of calculus is all about. So this is the identity that you see in front of you. Okay, this red finite difference is equal to the tangent line slope plus a difference. Okay, or this red finite difference is actually the slope of a non-parallel secant line. So how do we know that f prime of x is 2x and the slope difference is h? Well, we know from my theorem, okay? So if we go to my theorem, my historic geometric theorem, this is the one you should look at first, and this explains and gives you a proof of how you can know which terms are belonging to the derivative and which to the quotient. And there's also another article called the Theorem for Dummies, and it just shows you briefly how you can get both your derivative and your definite integral. Okay, so what I want to show you now is that these expressions here, the values for these expressions, are actually slopes, but they're not slopes in terms of angles, okay? Because if we took the angle of the non-parallel secant line and the angle of the tangent line, then this identity would not be true. It's only true if we take slope in terms of rise over run, okay? In other words, we're taking the tan of these angles here. Right, so we're taking the tan of these angles. That's very easy to see. You get a calculator, okay? Look here. So if we say, 73.439, and we take the tangent of that, okay, it's 3.6279, which is approximately 3.363. I could add more digits here if I wanted to by simply doing this and saying, go to 4 decimal places, or 5 even. Let's do 5, okay? So now you'll see that it's much closer, right? 3627, 3627. So there's a 9 there, there's an 8 there. No problem. Now, the same thing if you take the tangent of 63, it'll give you 2, right? See? And let's do that as well, just for completion. 63.43495. Approximately 2, okay? That's good because I haven't actually entered the whole thing. Otherwise, it would be 2 exactly, right? And I can't enter the whole thing. So 53.72894. That's the difference, isn't it? And see, 1.36278, 1.36277, whatever. Okay, so as you can see, what you have here is the identity in terms of rise over run. So when you say this, these parallel secants closely approximate the tangent of approximate the function tangent, they can never be the tangent, okay? Because if you go there, there is no more identity or anything. Do you see that? So and it's you cannot have a slope there if this is, hang on, you don't have a non-parallel secant line slope. So how are you going to get the rest? But now you do. So you can just ignore the slope difference, okay? But now, if you ignore the slope difference and you look at this in terms of its truth value, it will only be correct in the case of a straight line. Because if you take away this, then it's only true if f is a straight line. So there's no way you can just throw this away and this identity remains true in all cases. It is required for the identity. And I'll explain that all in a moment. In fact, let's do it now. So if we have a function like x squared, and this is the article here, and I'll put all this in a comment below the video, then this is the identity, right? And so from my theorem, we know that the parts are f prime of x and the difference. So you can't just throw away the h term and then imagine that 2x is equal to the limit of this thing, because this is equivalent to setting the difference to 0 or h to 0, the very thing that is anathema in the bogus mainstream formulation of calculus. Moreover, there is never any finite difference in the form rise over run when one considers the converging sequence of finite differences. So in other words, you cannot use the function alone to find the tangent line slope. You cannot do that because there's no way to express the tangent line slope in terms of f. Okay, so also this is really very confusing to students when they look at it, because they say, oh well, so somehow there is a rise over run, the ultimate ratio, but it's not part of the finite differences. So you have to imagine that it's kind of hovering somewhere over infinity of the sequence, but it's not even proven to be a number. That's the other thing. Okay, so this is equivalent to setting the difference to 0. And the next thing is, you can ignore the difference if all you want is a derivative. Okay, so that, and also you have to remember that tan of a plus b is not the same as tan of a plus tan of b. So if you come over here, the reason you cannot say 71 degrees is equal to 63 degrees plus 46 degrees is due to the fact that tan of a plus b is not equal to tan of a plus b. Get that? It's only true in terms of rise over run. Okay, so throwing away the difference term would render this identity, the Holy Grail, invalid, because it's, as I said earlier on, only true in the case of a straight line. Now, Q of xh doesn't approach or go anywhere, as those imbeciles like Gilbert Strang and his mainstream colleagues think. Q of xh is unique for every non-parallel secant line. Okay, so what does this mean? This means that it doesn't matter which parallel line you choose, yeah, this difference will be unique. Okay, and so no two non-parallel secant lines will have the same difference. So if you take this non-parallel secant line, it's 1.21. If you take this one, it's 1.072. They're all different. And they're not approaching anything or going anywhere, as your bullshit mainstream calculus tells you, okay? They're all fixed for every non-secant line. They're fixed. So Newton and Leibniz would have kissed my ass because I could explain what they could not. What did I explain? Why their methods worked. Okay, Berkeley was right in lambasting them, but he wasn't able to explain why their methods worked. So what you all need to do if you're a mainstream academic is you need to grow a brain, because you're a fucking imbecile. And you need to also admit you're wrong, because your grandchildren and your great-grandchildren, hopefully many of you won't have children, but if you do have, they're going to be laughing at you, laughing at your ignorance and your stupidity. How much longer can you deny this knowledge that I reveal to the world? I, the great John Gabriel. If you're not a raised subscriber, become one. Tell your friends about this channel. Click like and follow me on academia.edu, where I have many interesting articles, okay? Let's see, how many do I have? 254 papers. I actually have 3 books. 2 of them are part of this paper number. And that's pretty much it. Till next time, goodbye.